There are different kinds of chemical equations. What we think of as a regular chemical equation is the molecular equation. It shows the neutral formulas for all the compounds in the reaction as if they were existing as molecules. Now, ionic compounds never exist as molecules, but we can write formulas for them where we have the lowest ratio of the ions. And so this is a molecular equation. But in actuality, the potassium hydroxide here, being aqueous, is separated into potassium ions and hydroxide ions. So we can also write an ionic equation, sometimes called a complete ionic equation, which shows all the ions that are present. If it's a solid, the solid is not present as individual ions floating around in the water, and so we leave this one alone because this solid is magnesium hydroxide hanging out at the bottom of the beaker. And then the net ionic equation only shows the species that are actually changing. Some of the species, like here potassium came in, it was with a soluble anion, it wasn't in a relationship. And here, after magnesium and hydroxide get together and precipitate, potassium is still just in solution. Nothing happened to the potassium. So to write complete ionic equations, you take the molecular equation and you separate aqueous things and write them as ions. The molecular equation. So here we have the molecular equation, and we're going to make a complete ionic equation out of it. So we look at this and we see, well, that's aqueous. So we're going to write those as the individual ions. So that's lead 2 and 2 nitrate ions. So NO3, and there's 2 of them. Here we have 2 units of KCl. It's also aqueous. And so when we separate that, we have 2 potassium ions and 2 chloride ions. Over here, we have lead chloride, which is a solid. And so we're going to just leave that alone. If you have solid, liquid, or gas, SL or G as the state symbol, don't do anything to it. Just copy it down. So we copied that one down. Here we've got aqueous again. We need to separate this into ions. It's 2 potassium ions and 2 nitrate ions. And that's the complete ionic equation because it has all the ions. We're taking all the aqueous things apart. Okay. Yep. But anything that's a solid, liquid, or gas, we leave it. And we'll talk about this a little bit later. If you have a weak acids don't ionize completely. They only ionize a little bit. So we don't separate weak acids. But that's kind of a minor point here. For the net ionic equation, net means sort of the bottom line, right? Your net paycheck is after they took out taxes and all kinds of other stuff, right? That was your complete paycheck. The gross pay, the net pay is they took some stuff out. The net ionic equation, we've taken out all the extra stuff. So here's our complete ionic equation, just the same one we had on the previous. And if we look at this, we see that there are 2 nitrate ions as reactants, and there's 2 nitrate ions as products. Nothing happened to the nitrate. We call those spectator ions because they're just watching, right? Something happened with the lead and something happened with the chloride. They fell in love, right? They got together. But nothing happened to potassium or to nitrate. They're just watching. They're spectators. So for the net ionic equation, you just cross off the spectators. I know, right? The more ridiculous it is, the better. So you just get rid of the spectators. So it's like, hey guys, get out of here. Leave these guys alone. Nothing happened to you. Go away. There's nothing to see here. And then what do we have left? We've got Pb2+, we've got 2Cl-, forming PbCl2, and we write that down, and that's our net ionic equation. That's showing us what actually happened. Nothing actually happened to potassium and nitrate. Were they there? Yeah, they were there, but they didn't get changed. Any questions about that? So let's practice writing some ionic equations, complete ionic and net ionic. So here we have a reaction, 2HI aqueous, BaOH, 2 aqueous forming H2O liquid, and BaI2 aqueous. We don't have to think about solubility here because the state symbols are given to us. But we're supposed to write the complete ionic equation and the net ionic equation. So if we see AQ, we're probably going to separate it into ions. We're not going to worry about the acids yet. That's a strong acid, and so we're fine. So I see HI. I have 2 of them, and so I'm going to end up with 2 hydrogen ions and 2 iodide ions. That's from this guy right here. And then this one's also aqueous, so I'm going to separate that into ions. That's going to give me a barium ion. And I've got hydroxide ions, but there's 2 hydroxide ions. You with me so far? In the products, water is a liquid. If it's a liquid, a solid, or a gas, just copy it down. Don't mess around with it. So I just write 2H2O liquid plus, and then this one's aqueous, so I need to separate that into ions. A barium ion and 2 iodide ions. You can probably see that if you're weak on your ion formulas and making compound formulas and things, you're going to struggle with this. So there's my complete ionic equation. Going from this to the net ionic equation is relatively simple. I'm going to look for things that didn't change. They're the same on both sides. So what's one ion that appears on both sides? The Ba2 plus. Yep. Yep, I've got Ba2 plus on both sides, and I have 2 I minus on both sides. So I cross those out. And my net ionic equation, I'm just going to write down what's left. Mm-hmm. Yep. That's the net ionic equation. So originally here where we had iodide, would it matter if that was maybe chloride instead? Or bromide? No, because nothing happened to it. Here, the hydroxide got involved with something. If we had carbonate here or sulfide here instead, then the reaction would be different. But we have some spectator ions. Now, this is not the best chemical equation.
I have a question.
Mm-hmm.
Okay, so you see it's on the second plot, the 2H2O,
Mm-hmm.
and then at the bottom it's 2OH. Why did you switch it?
This 2OH is this 2OH.
Yeah, but like, you see on the black writing it's H2O on the other side. Keep going that far.
This is H2O, and this is H2O, and this is H2O. They're just not lining up very well. I've got coefficients of 2 in front of everything. Usually for our chemical equations, we want the lowest coefficients that are whole numbers. And so ideally you would say H plus OH minus to make H2O. I won't try to trick you with stuff like that. Mastering chemistry might, I don't know. Any questions? So